Okay, today's video is going to be about finding the area of a regular polygon. So remember that a regular polygon has all equal sides and all equal interior angles. So in your discovery, you were given a regular polygon, and then you picked the sides. So we picked 6 sides. And then using the different sliders, it took apart the polygon, our hexagon, into 6 different triangles and then laid them out. And then doubled them, so you actually had 12 triangles lined up. And when you line them up like this, it gives you a parallelogram right here. And we know how to find the area of a parallelogram. It's the base times the height. And in this case, this is the base. And then the height is anywhere along one of these triangles perpendicular to the base. So when we look at the base here, the base is actually the measure of the perimeter of our regular polygon. So the base is actually the perimeter. And then the height here, that's perpendicular, it is actually a segment called the apothem. It's a special segment that's perpendicular to the sides of the polygon. You can see it here is the same spot that it would be. And so we use that to find the area. Now, this parallelogram is twice as much as we would need. So we actually need half of this base times height. So the area for a regular polygon, you should have found out, was 1/2, instead of base, the perimeter, we use a capital P, times the apothem, which is a lowercase a. So we'll be using that formula in our examples. So there is the formula again, one more time, perimeter and apothem. Then it shows you here that CS is the apothem. It's from the center and perpendicular to the side here. And then the radius is actually from the center to the vertex. So in our case, it would be right there. And so that is the radius. Sometimes you could be given the radius, sometimes you could be given the apothem. So example number 1, we're going to find the area of a regular pentagon. In this case, they gave us a side length and the apothem length. So area equals 1/2 perimeter times apothem. And I like to just write it with parentheses around it so I don't forget. So the perimeter is going to be the side length, 11.6, times the number of sides that we have, which is 5. And then the apothem is actually 8.0. So 11.6 times 5 is equal to 58. So now I'm just going to plug all that in. Area is 1/2 times 58 times 8. And you can do multiplication in any order. So I'm actually going to take half of 8, which is 4, and multiply that by 58, because it's a little bit easier. And I get 232, and we are in centimeters, and it's area, so centimeters squared. Okay, example number 2. In this case, we're actually given the radius. We are not given the apothem here, so we're going to have to find that. This is a hexagon, so we're going to have to use these interior angles to find our missing side lengths. So just a reminder, area equals 1/2 perimeter times apothem. So we're looking for the perimeter and we're looking for the apothem. In order to find the perimeter, we need to find this side length right here. And we're going to do that using this triangle. So if you remember your interior angles for a hexagon, this interior angle right here is actually 120 degrees. So this angle in here is 60, which gives us a a special right triangle, a 30, 60, 90, with a hypotenuse of 4. So using our special right triangle rules, we know that the side opposite the 90 is 4, so the side opposite the 30 is 2, the side opposite the 60 is 2√3. So the apothem is 2√3, and then that would make this little side 2 here and 2 here, so this whole side would be 4. We could have also found that out by drawing in this equilateral triangle, because all of these angles would have been 60, so we know that they're all 4. So the perimeter is the side length, 4, times the number of sides, which is 6, so that's 24. So So we're going to plug all of that in. Area is 1/2 the perimeter, which is 24, times 2 root 3. So there's more than one way to solve it here. You could take half of 2 or half of 24. Either one would work. Half of 24 is 12. 12 times 2 is 24, so back to our 24. And we get 24 root 3, and we are in meters squared. All right, for our third example, we have a hexagon inscribed in a circle, and they actually want to know just the area of the shaded region. So again, we're given the radius of 10. So here we have a circle with a radius of 10, and we have a hexagon with a radius of 10. So first we're going to find the area of the circle, then subtract the area of the hexagon to find what is left over. So area of a circle is pi r squared, the radius is 10, so area equals pi 10 squared, 10 squared is 100. So we have 100 pi centimeters squared for our area of a circle. For our hexagon, I'm going to draw in our radius over here, just so it looks nice, 10. And then the apothem and this side length is what we're looking for. So remember that you get an equilateral triangle here, so these are all 60. So I already know that this side length here is actually 10. So when I'm finding the area using the perimeter and apothem, the perimeter is actually going to be 10 times 6, because there are 6 sides, so that's 60. So now I need to find the apothem here, which would come from this 30, 60, 90 right triangle with a hypotenuse of 10. So that would make this 5, and this 5 root 3. So the apothem is 5 root 3. So now I'm just going to plug all that in. 1/2 the perimeter, which is 60, times 5 root 3. So half of 60 is 30 times 5 root 3. So I get 150 root 3. So now I'm going to subtract them. So I'm going to take the area of the circle, which is 100 pi, and subtract the area of the hexagon, which is 150 root 3. And this is going to be centimeters squared. And that is going to be my area.